Hello, welcome to part 5 of Windows Server 2012 course. We spoke earlier about Storage Space Direct or S2D, and for today's topic we will continue to the previous session, Resilient File System. What is it? Resilient File System, REFS, it's a new local file system introduced in Windows Server 2012. Maximize data availability and online operation despite error that would historically cause data loss or downtime. The data integrity built into the resilient file system ensures that business critical data is protected from error and available when needed. The RAFS architecture is designed to provide scalability and performance for constantly growing data set sizes and dynamic workload. Technical overview. REFS is designed with 3 key goals in mind. REFS maintain the highest level system availability and reliability possible under the assumption that underlying storage may be inherently unreliable. REFS provides a full end-to-end resilient architecture when used in conjunction with storage space, so that these two features magnify the capabilities and reliability of the other when used together. REFS maintain compatibility with NTFS features that are widely adopted while replacing features that provide limited value. Some of the REFS features: robust disk updating. REFS offers robust disk updating with an allocate on write transactional module, also known as copy on write. This approach maximizes reliability by avoiding problems associated with power failure during disk update. This is accomplished by updating data with writes to different locations in an automatic fashion rather than updating data any place. Data integrity. To enable detection of all forms of disk corruption, all file system metadata is updated using allocate on write and is additionally protected with checksums. REFS include the optional ability to apply data integrity to user data as well. When this option, known as integrity streams, is enabled, REFS always uses allocate on write for update to user data and uses checksum to detect disk corruption. Mechanisms and APIs are provided to enable or disable integrity streams settings at various levels of granularity, including per volume, per directory, and per file. When REFS is used in conjunction with a mirror storage space, detected corruption, both metadata and user data, when integrity streams are enabled, can be automatically repaired using the alternate copy provided by the storage spaces. Availability. REFS is designed to maximize online operation even if corruption occurs. While it is expected that many customers will use REFS in conjunction with mirrored storage spaces to automatically repair corruption transparently, it is still possible so rare for such a volume to become corrupted. Additionally, some enterprise customers might choose not to utilize mirrored storage space for their REFS volume. In these cases, when corruption does occur, REFS implement salvage, which is a feature that will remove corrupted data from the namespace on a live volume so that good data is not adversely affected by non-repairable corrupted data. This ensures that volume do not have to be taken offline to correct errors. Also allow all the admins to simply restore file removed from the namespace by restoring them from a backup. There is no check disk with REFS. Scalability. As the amount and size of the data increase rapidly, REFS is designed to work well within or with extremely large data sets, petabytes and larger, without performance impact. While practical concerns surrounding system configuration, such as the amount of memory, limits by the various system components, and the time taken to populate data sets or backup time may define practical limitation. REFS on a disk format is designed to support volume sizes up to 2 power 78 bytes utilizing or using 16 kilobyte cluster size, while Windows stack addressing allows 2 power 64 bytes. This format also supports 2 power 64 minus 1 byte file sizes, 2 power 64 files in directory, and the same number of directories in a volume. We can see the difference between REFS and NTFS and the benefits RFS will basically provide. Additionally, application compatibility. REFS maintain high degree of compatibility with a subset of NTFS features that are widely adopted while deprecating other that provide limited value at the cost of system complexity and footprint. REFS supports most NTFS features and Win32 APIs. Proactive error identification. REFS integrate with data scrubbers or data scrubber that periodically scans the volumes, trying to detect latent corruption, and when running on top of a mirror storage space automatically repairs corrupted data. Last one is the interoperability and flexibility. REFS is designed to fit cleanly into Windows storage stack with compatibility with other layers of stack, while extensively tested to ensure compatibility with other supporting software such as backup and antivirus application. REFS is designed to work well together with features in other layers of the storage stack. One of the best examples of this when REFS is used in conjunction with storage spaces. REFS can seamlessly take advantages of storage pools shared between multiple machines and virtual disk that can seamlessly transition between them, providing additional resiliency to failure above what storage spaces can handle or RFC could do alone. REFS can be installed on a third-party storage subsystems as well, not only Microsoft subsystems. DataCenter Diskless boot. DataCenter Diskless boot. The Microsoft iSCSI software target feature is built into Windows Server 2012, and it lets you create a storage area network, or shall we say SAN, device on a hardware running Windows operating system. We will highlight that one later on at another course for Windows 2016. iSCSI software target also enable you to network boot multiple computers from a single OS image that is stored in a centralized location. This improves efficiency, manageability, availability, and security. iSCSI software target in Windows 2012 can boot hundreds of computers by using single operating system image. So, what do I need to have in order to utilize iSCSI? These are the requirements. iSCSI software target can be installed as a part of file server role. Management is provided through the server manager. Automation can be achieved by the corresponding Windows PowerShell CMDLET. This feature does not require special hardware for functional verification. In data centers with large-scale deployment, the design should be validated against specific hardware. Second part of the requirement, it's the operating requirement. For reference, Microsoft internal testing indicate that for 256 iSCSI boot deployment, 24 times 15k minus RPM revolution per minute, disk in a RAID 10, or shall we call it a mirror. Configuration were required for storage. A network bandwidth for of a 10 GB is optimal. A general estimate is 60 iSCSI boot server per Windows Server 2012. 1 GB network adapter. However, an iSCSI boot capable network adapter is not required for this scenario. If the network adapter does not support it, a software bootloader can be utilized, such as iPXE, open source boot firmware. Technical overview for the iSCSI. The technical overview software target feature in Windows Server 2012 support diskless network boot without the need for a special hardware or additional software. iSCSI software target fully complies with iSCSI protocol in RFC 3720. A key component to this feature is that it supports differencing of virtual hard disk. This is critical in the boot scenario because multiple servers running Windows Server 2012 can boot by utilizing or using only one base image. iSCSI software target accomplish diskless boot as follows. iSCSI software target support creating differencing virtual disk based on a golden image or gold image. Each diskless client boots from its own differencing virtual disk. The diskless client reads from the golden image and writes to its own differencing VHG. Because the image is hosted in a centralized place, storage space saving are realized on operating system deployment. That can translate into a freed up storage spaces that was previously allocated to operating system boot image, or budget saving because you no longer need to purchase a hard disk for this purpose and the power to cool them, UPSs. In Windows Server 2012, the scale of iSCSI boot has increased to 256. Therefore, the cluster target can support 256 boot clients, and it does not experience Next is encryption of your hard drive. Encrypted hard drive feature in Windows 2012 uses a rapid encryption that provided by BitLocker drive encryption to enhance data security and management by offloading the cryptographic operation to the hardware. An encrypted hard drive increases BitLocker performance and reduces CPU usage and power consumption. Because encrypted hard drive encrypt data quickly, enterprise customers can expand BitLocker deployment with low impact on productivity. Requirement to utilize encryption: Windows 8 or 2012 for data disk and unprovisioned disk that support encryption or encrypted hard drive, for startup disk and provisioned disk that support an encrypted hard drive, and a computer that include a unified extensible firmware interface or UEFI class 2 or native with UEFI 2.3.1 support. Technical overview: rapid encryption in BitLocker directly addresses that security need with significantly improved performance. In the earlier version of Windows, BitLocker required two steps process to complete read and write request, but in Windows Server 2012, an encrypted hard drive offload the cryptographic operation to the drive controller for much greater efficiency. When Windows Server 2012 initialize encrypted hard drive, it activates the security mode. This activation lets the drive controller generate a media key for every volume that the host computer creates. This media key, which is never exposed outside the disk, is used to rapidly encrypt or decrypt every byte of data that is sent or received from the disk.